Good morning, Tehmina Khan is here in TKMaths S1. In today's video, I will explain to you the A-level mathematics syllabus P1, differentiation. The topic is differentiation, and this lesson is introductory lesson in which I will tell you what is the requirement of the syllabus and little bit about the concept. I have not explained all the pointers or all the requirement of the syllabus with the help of the examples. For examples, you need to see my videos which are available on the blog tkmaths1.blogspot.com, and you can see it from there. So the purpose of this video is to make you aware what is the requirement of the differentiation and what are these things. So if we look at the syllabus here, first of all, it's written very small. You don't need to read it because all those lines which are highlighted, I have explained in this video. So the point here is whenever you're studying, do read the syllabus. This basically tells you what you need to know. And there is little explanation of whatever they are explaining here. So I have explained all this in this video. So let's just start with the first point. So number one thing is that you need to understand the definition of what is the gradient of a curve at a point. And the concept comes from 11 maths when you do first time the tangents of the curve. So when we say gradient of a curve at a point, it means, if you remember in 11 maths, you used to draw graph. And if you have to find tangent, for example, at this point, and suppose this is minus 2.5. So you used to draw tangent line there. And then you used to take 2 points on the tangent and apply this gradient formula to find out the gradient of the tangent. Now, the gradient of the tangent is actually the gradient of the curve at this point. But because in calculus in A-level AS maths, we are not drawing graph to find the gradient of the curve at any particular point. So we use calculus, which is differentiation. So I have done here, you do differentiation, first derivative, which is also represented by this. And the method is, you remember, you multiply by the power, 3 to the 6, and subtract the power by 1. This is for polynomial functions. And then this one will become 2x, and differentiation of 1 is 0. Constant is 0. So this gives you gradient function. So whenever you differentiate the function you get, it helps you to find the gradient on different points on this curve. So you just need to plug in the value of x. So now if you plug in 2.5 in this equation, by the way, this equation is not representing this curve actually. I've just taken a random example here to explain the concept, right? So to finding the gradient of a curve at a point means you have to differentiate the equation. You have to plug in the value of x because it gives you gradient function. So, and these are the notations of first and second derivative, which you need to know. This single prime and dy over dx is first derivative, and this double prime and d square y over dx square is second derivative. We will see this also in the video ahead. Second thing is the use of derivative of x power n together with constant multiples, sums, and difference. What does it mean? Where n is a power which is any rational power, right? So these are the examples. Few examples, not all. So you know, you are taking power, you are multiplying, you are subtracting, you are taking root. So these type of polynomials, these type of functions, expressions, you need to know how to derive it, right? And I have explained it here, and you know the basic differentiation. So the requirement of the syllabus is that you need to know how to handle these type of expression, how you will differentiate them to find out their gradient function. Okay. Then it comes composite function using the chain rule. Now here it is, usually the understanding, this is called a composite function, right? Now when students have to differentiate it, they learn a very basic thing. Most of the students usually do not know the background. When the syllabus says using the chain rule, actually what happens in the background when you are differentiating it. So I'll explain you here. But otherwise, if you remember, what do? We bring the power here, 4 comes here, this remains as it is, right? For example, if I write here, what usually you do, 4, function remains as it is. You subtract the power by 1, it becomes 3. And then you multiply by the differentiation of the function inside the bracket. So it becomes 3x square plus 0, right? This is what you do. But actually what happens, chain rule works behind this. For example, you say, okay, let u is equals to this, x cube plus 1. So your function become y is equals to u power 4. You can see here, y is equals to u power 4. Now y is connected with u. So you can differentiate y only with respect to u. But what question is saying? Find dy over dx. So you apply related rate of change. You see here, dy over dx is equals to dy over du into du over dx. If you want to see in detail, I am attaching the link of the video where I have taken example to explain this concept. It is in the description, so you can see that. It is explained more in detail there. So after making this chain rule, you plug in the values here. Now dy over du will be 4u cube, right? 4u cube, which is here. And du over dx will be what? If you differentiate du with respect to dx, it will be 3x square. Correct? So after that, you get this thing. And then you are replacing u by the substitution you have taken here. So you will substitute this value of u here. And this is how you get this. So usually students do not do this. It is not the requirement also to do this, but you need to understand how it is working, right? So the reason of this when students do it directly is basically chain rule works behind it. Then the next requirement of the syllabus is apply differentiation to gradient, tangent, and normal. Now what does this mean? So look at this example. An equation of the curve will be given to you. And when you differentiate it, right? We have just seen in the previous slide, when we differentiate a curve, for example, it is this curve, you get the gradient of this line and the gradient at this point on the curve. So it is understood that whenever we differentiate the curve, we always get the gradient of the tangent because that gives us the gradient of the curve at that point. And since normal is the perpendicular, we know it from coordinate geometry concept. So the difference or the relation between the gradient of tangent and normal is of, when you multiply the two gradients of normal and tangent, the answer is -1. So for example, the gradient of tangent is 2 upon 3. Then what will be the gradient of the normal? -3 upon 2. So whenever you have to find the equation of the normal, and of course to find the equation of the normal, which is a straight line, you need a gradient. So you differentiate and find the gradient of the tangent first. Then you take opposite sign with inverse of the number and you get the gradient of the normal. So this concept you need to know. Then you need to know what is increasing and decreasing function. Now, increasing and decreasing function mean, now if you remember from coordinate geometry, when the line has this shape, it is positive gradient, right? When the line has this shape, this way, it is negative gradient. So when the gradient dy over dx is greater than 0, we say increasing function. So for example, this is the curve. You don't need to draw the curve every time. I mean, I'm just going to explain it to you. So in this curve, if I see, for example, the value of x from here onward, the shape of the curve is like this. So it is increasing function here. Whereas at this point, whatever the value of x is, if I see left hand side, the curve has this shape. So again, it is positive gradient. So these are the values of x. Suppose x1 and x. So greater than x and less than x1, the function will be increasing. Similarly, for decreasing function, you do dy over dx. Actually, this is forming an inequality. So when you solve this inequality, you get the values of x. So those are the values of x. For example, in this case, you get these values of x when you will solve it. So you will say, okay, so these are the values of x which will give me decreasing function. You get my point? So whenever we say increasing or decreasing function, you will apply this concept in your mind, because you see visualization is insight, it is not picture. So basically it helps you to understand. And I'm making video on increasing and decreasing function. So again, you can see the explanation in more detail in those videos. Okay. So, and the link you can find from my blog, tkmaths.blogspot.com, right? Then you need to know rate of change. We have just discussed in the example also. So you need to understand this concept also very well. It can be with respect to area of a circle, circumference of a circle, volume of the sphere, you know, so different relationship, volume, area, radius, these type of things. So you should know how to apply rate of change, related rate of change here. Now the next point is a stationary point you need to understand. Now what is the stationary point? The stationary point of a curve are the points where the gradient is 0. Now we know gradient is basically the slope of the line we are talking about. So when the slope of the line will be 0? When it is horizontal, right? So let's see an example here. I have just picked up these examples from different sites of internet, thanks to people who share their efforts, like I'm also sharing free videos. So thank you for those people. I've given link of these videos, or I mean, from where I have taken these snapshots, I've given the link in my videos, in this video. Okay, so now if you look at this curve, for example, this is the maximum point, right? And this is the minimum point. If you draw tangent here, it will be a horizontal line, horizontal to x-axis. So the gradient will be 0. So that's why we said dy over dx equals to 0 at a stationary point, at turning point, right? At maximum point, local maximum. Achha, by the way, why it is called local maximum and local minimum? You know why it is called local maximum? Because you see the value of y you get here is not actually the maximum of the curve. Curve is going up on this side also, going on up. So that's why in this surrounding, at this turning point, this point is maximum here. So that's why it is called local maximum or local minimum. So I'm coming back. So stationary point of a curve are those points where the gradient is 0, right? And by the way, all these stationary points are not turning point. So this we will discuss later. Okay, so next concept. A stationary point and determine their nature. Now what actually happened when this type of question comes? Because if you do not, if one is not have visualization, because in this video I have tried to give you the visualization of the topic. So if you do not have, or if anybody does not have, what do they do immediately? Because I teach and I experience in the class. So mostly this is what students have. The moment they hear the word stationary point, they know dy over dx equals to 0. They solve the equation, this equation, get the value of x. And that value of x they plug in the original equation of the curve and get the value of y. So they get the point at which there is gradient 0, the stationary point, right? Now, second thing, if they have to find the nature, either the curve is maximum or minimum, simply apply the concept d square y over dx is square greater than 0. Mean they differentiate it, and the value of x they have gotten from here, they plug in the value in that double derivative equation. And if the answer is positive, greater than 0, it is identified that yes, it is a minimum value curve. Whereas if the answer comes negative, it is a maximum value curve. So I will show you this with the help of example. And after that, I will explain with the help of a sketch the understanding of all this concept. So this video will be a little longer because first of all, I'm showing you the working, which is the requirement of the paper, which mostly students do. And then after that, the sketching for the understanding basically. So let's look at this example. If we have to find the stationary point and we have to find the nature of that point, either it is maximum or minimum. So what we will do? We differentiate it, right? And we are differentiating it again because we will need it. So differentiation, you know. The differentiation of this is 3x square plus 6x minus 9. And double derivative, this we will need to find out the nature. So at the moment, we will use this. So for the stationary point, we will put this equals to 0. And we will solve this equation. Now, when we will solve this equation, I think you know how to factorize it, how to do middle term breakup. You got two values of x, minus 3 and x is equals to 1. So now you know okay, at this point of x, you will have a stationary point. Now, to find out the y coordinates, what we will do, we will plug in these values of x in this equation, actual equation of the curve, right? To find out the corresponding values of y. So now, first of all, we are plugging in x equals to minus 3, right? In place of this. And we got answer 37. So one point is minus 3 comma 37. Then we are plugging in x equals to 1. So the points we have identified, minus 3 and 37 and 1 and 5, 1 comma 5. Now we have to find the nature. Okay, at 1 comma 5, it is maximum or minimum. At minus 3 comma 37, it is maximum or minimum. So we will use double derivative. So we have already differentiated it. So second derivative is basically helping us to find out the nature. So now in this equation, I will plug in these values of x, okay? So when x equals to minus 3 is substituted here, the answer is coming minus 12, which is less than 0. So we have seen when it is less than 0, it is maximum. So you can say at point minus 3 comma 37, it is local maximum, right? Or maximum value. And when you plug in x equals to 1, in this derivative, second derivative, your answer is coming 12. Now it is positive answer, so you can say it is a minimum value, right? So we have already seen this. Okay, whenever we see double derivative less than 0, it is maximum. When it is greater than 0, it is minimum. So now here, the concept or the requirement of the syllabus is over. So if you are interested to know the visualization of this stationary point and its nature, which is very important, especially there are questions at time asked where you need to visualize this concept. Only then you can solve it, right? Because they are thought-provoking question, not a straight away. So let's see the visualization of this stationary point and its nature concept. And I have given you the link here, which helped me to take the clips from there. Otherwise, it would be a little lengthy to work on it. Okay, so now this is the equation, right? X cubed plus 3x squared minus 9x plus 10. Now, if you plot this curve, right, this is the curve you will get. And the gradient of the function, when you differentiate it, you get this. We have just seen this. And we have seen this whole solution behind. So basically 3 comma 37 is basically this point. And 1 comma 5 is basically this point. So this is the number one concept, that when we are differentiating and when we are finding the points, it is basically giving us these points, right? Number one visualization. Number two, when you differentiate it first time, of course, this is a gradient function, right? If I plot it, this is here, plotted here. So what is the relation between this curve and this curve? What we know so far is that whenever we plug in the value of x here, it gives us the gradient at that point on the curve. For example, if I substitute 3 in this gradient function, I will get the gradient at this point, right? So when we are solving this equation, gradient function, what are these answers actually on this graph? So on this graph, this is a gradient graph, gradient function of this curve. Minus 3 and 1 are the x-intercept, because now this curve is dy over dx is plotted against x. It is not y plotted against x. You get my point? So now your y-axis is actually your dy over dx. So number one visualization is that these x coordinate on the function, if you plot, gives you the x-intercept. And you can see exactly what was your maximum x value, which was -3, is now your x-intercept, right? So second visualization. Third is, when we say d square y over dx square is negative, if it is negative, it is maximum. Why? Right? So if you see here, this side of the curve, what is the shape? It has negative gradient. We have just seen in the previous slides. Okay? So this is negative. So that's why when you plug in -3, you can see on this curve, the gradient is negative. And that is the reason we say when d square y over dx square is negative, it gives us maximum curve. So this is basically gradient of the gradient. By the way, this term is used at times in the question. So students need to understand what does it mean, right? So let's see the complete thing. So tangent at this point is basically negative now. This is what I've explained to you. So now we understood here why when d square y over dx square is less than 0, and we substitute the value of when we substitute the value of x in it and we get answer less than 0, we called it maximum value of curve. So this part of the curve is explaining it to you very well, the reason of it. So now you can visualize it. Similarly, we can see on the for the minimum, it was 1. And when you sketch the graph of gradient function, it was passing through 1 on the x-axis. And the gradient here is positive. So the gradient of the gradient is positive, and that's why we call it minimum value curve, right? So thank you very much for watching this video. If you have learned something or liked it, please press like and subscribe button and share it with your friends. And once again, I'm telling you, I have explained all this concept with the help of past paper questions in detail. So you need to go to my blog address or my website address. The links are available here, user friendly. And it is few are given in the description also, because few videos I have made and few are still left to make. So thank you very much. Take care. Allah Hafiz.